In this lecture, we will see the schematic diagram of a half subtractor using transmission gate, and then we'll see the twistor schematic and then the layout. Half subtractor using transmission gates So let's see what's a half subtractor. We have two inputs in a half subtractor, A and B. The operation is A minus B. So when there is a subtraction, we get two outputs. That is, we'll have a difference and a borrow. Okay. So let's see the truth table of a half subtractor. The truth table is, let's say this is A, B, then we have difference, and then we have borrow. Okay. When the input is 0, 0, then the difference is 0. The borrow will be also 0. When 0, 1, 0 minus 1 is not possible. So there will be a borrow, and the difference is 1, 0 minus 1, that is 1. When it's 1, 0, the difference is 1, borrow 0. When 1, 1, the difference is 0, borrow is also 0. So if you try to express this difference in borrow, after you draw the K-map, difference is A XOR B, or A bar B plus AB bar, and the borrow is equal to A bar B. So if you try to represent this at gate level, then it's this is A, this is B. So the output is A XOR B. When we say A bar B, then it's like this, A bar B. So this is your difference, this is your borrow. So this is the gate level representation of your half subtractor. Okay. Now after representing at gate level, we have to now represent it in a schematic form. So when you try to represent in a schematic form, we'll use the PMOS and NMOS either to operate this A bar B plus AB bar. We can design in this way, or by using transmission gates. So we will prefer by using transmission gates. So let's see how to design the schematic diagram. We'll see the schematic diagram of a half subtractor using transmission gate. Using transmission gates. We know very well that there are two inputs and two outputs. One of the output is the difference, which is A XOR B, and we already know the how to draw the schematic using the transmission gates for a XOR gate. So we'll see first the A bar B. So what was the output of A bar B? If it's A and B, output A bar B for 0 0, 0 1, 1 0 and 1 1. For 0 0 it was 0 1 0, now 0. So you have to keep in mind that first design a transmission gate. Okay, this one is for the borrow. Okay, because we already know the schematic diagram for the difference. Okay, and this is difference, this is A, this is A bar, this was B, B bar, B. So this should be B bar and this should be B because they run in complementary form. If it's B, here it's B bar, B, B bar and B. So what should be this input? We already knew this part. We had already designed the XOR gate. So over here, we have to see when it's 0 0, my output is 0. When B is the controlling input, you have to keep in mind B is the controlling. When it's 0, when this B is equal to 0, B bar is equal to 1, this is equal to 0. So this will turn off. When B is 0, this will turn on. So alternately they keep turning on and off. When B is 0, these two will turn on. This is 1, 2, 3, 4. When B is equal to 0, then 1 and 3 will turn on. When B is equal to 1, then 2 and 4 will turn on. So when B is 0, whatever will be there over here will be seen at borrow. That means that should be 0. And over here, whatever will be at A, you'll see in the difference. Okay. So if this should be 0. First it should be 0. Okay. Then when B is equal to 1, that means 2 and 4 will turn on. Whatever will be there here, you should see over here. That means the output is 1. So here the input should be 1 in order to get the output 1. Again 0, 0 should be there in order to see in the output. So 0 again. So there should be 0 always. When it's 1, it should be 0. It's not 1, it's 0. So if you see these two cases, in 0 1 case output is 1, in 1 1 case output is 0. That means whatever the value of A, the reverse is seen in the output. So this should be A bar, and this is connected to ground. So you got the output here. Similarly, in the case of the difference, A, B and output, that is difference. So when it's 0 0 0 0 1 1 1 0 1 1 1 0, that is the output of XOR gate. That means it's 0, output is 0. When next 0, output is 1. Here is also 1. In 0 1 0 1 for the case of 0, that means it is same as A, so A is written here. When B is 1, then obviously this will turn on. Here 0, if A is 0, output is 1. If A is 1, then output is 0. So that's why it is written here A bar. Okay. So this is the schematic diagram. Two things left, that is A and A bar, B, B bar. So there should be two more inverters. This is VDD. This is ground. This is A and this is A bar. If it's A, then only this is A and rest all are A bar. So just connect like this. This is A bar and this is A. Okay. Now similarly we have B and B bar. This is B and this is B bar. VDD and ground. This is B, so B is connected. This is B bar. This is B bar. This is B bar. Okay. Similarly for B, you'll connect This is for B. Okay, you have to just draw it a bit more neatly. This is a schematic diagram of a half subtractor. Next, we'll see the twistor schematic diagram. We'll see the twistor schematic diagram. The twistor schematic diagram of a half subtractor. Okay. Now for the twistor schematic, we know there are total 6 PMOS and 6 NMOS. So we'll draw six PMOS. This is the second PMOS. Then third, fourth, fifth, and sixth. Similarly over here, second. Okay, we'll just erase this. This is third, fourth, fifth, and this is sixth. Okay. This is P1, N1, P2, N2, P3, N3. Okay. Can just erase this line. This is P4, N4, P5, N5, P6, N6. These are the sources, drain, source drain. This is drain, source drain. Similarly, source and drain. So now the first thing is to draw the poly layer, that is the gate. So first to add the transmission gate. So the gate of the first PMOS is connected with the gate of the second NMOS. Then the gate of the second PMOS is connected with the gate of the first NMOS. This is a inverter, so the gate of the PMOS and NMOS are connected. Similarly over here, the gate of this PMOS is connected with gate of this. And gate of the second PMOS is connected with the gate of the first NMOS. And the gate of the second PMOS and NMOS are connected. So now the source of PMOS and NMOS in a transmission gate are connected. Similarly, the drains are also connected. The source from here is connected with source of this. Okay. So now this source, the source of the inverter is connected to VDD. Source of the NMOS is connected to ground. Then the drains are connected. Okay. Now here also we'll connect the sources and the drains, then sources and the drains. Here the source of the PMOS, source of the NMOS. So these are connected to VDD. These two are connected to ground. Okay. Now the drains of the PMOS and NMOS converter are connected, which gives you the output. Now here this is the input B. So B is connected to this. So we directly connect from here. This is input B. This is B bar. So from here B bar is connected to here. So you have to place a contact over here. So we just draw like this so as to just specify that there's a poly contact here. Okay. So this is B and this is B bar. This is connected to ground and this is connected to A bar. So that we'll see later on. Could do one thing. Okay, this is fine. So now for this also, this is connected with B and this is connected with B bar. So from here directly you can connect with B bar. So there will be a poly contact. Okay, this is connected with B. So from here connect from here to this. Okay, now this is B and B bar. Now this is A This is A bar. So this A is connected with this, and A bar is connected with this. So now how will we connect? From here we can bring the metal layer. This is A. So from here we'll bring the layer up to this. This is A. There is a overlapping, so we'll place a poly contact in the layout. Just for marking, we are placing this black squares. Okay, now A is connected. Next, the A bar. For A bar, it cannot be connected from side, so you have to connect from outside. So this is A bar. This A bar can be connected from, okay, this is connected from here actually this should be a bit below, so while drawing the layout we will be careful. So this is A bar, so here it's A bar, here A is connected. Now here ground is there and here it's A bar, so this A bar will be connected from outside. Okay, this is A bar. In order to connect this with ground, can't take from here because there's a metal layer, so we'll take through the poly layers. So this is your ground. Now the output is taken from the drains, so drain of the two transmission gates are shorted. This is your borrow, these two will have the difference. Okay, so this is the schematic diagram of a half subtractor. Now let's see the layout of a half subtractor from the twisted schematic diagram. Layout of from the twisted schematic diagram. Okay, so there are 6 PMOS and 6 NMOS. So first we'll draw the PMOS layer. First we'll draw the anvil and then the P diffusion layer. So I think this much space is not sufficient, so since there are 6 PMOS, we'll take a larger area. This is the anvil. Now we need the P diffusion layer. So we need 6 P diffusion layer. Three, 4, 5 and 6. This is the P diffusion layer. Or the P diff layer. After drawing the P diffusion layer, next you have to draw the N diffusion layer. So this is, there are 6 NMOS, so there will be 6 N diffusion layer. One. You have to make sure that the N diffusion layer are just along this. Third. Fourth. And this is the 6th one. This is the N diffusion layer or N diff. So now after drawing the PMOS and NMOS, next you have to draw the terminals. This is the source. This is source, gate and drain. Source, gate and drain. Source, gate, drain. Source, gate and drain. So now you have to draw the transmission gate. These two are the transmission gate. This is a inverter. or a NOT gate. These two are transmission gates, and this is again a inverter. So we can just extend this. Now the gate of PMOS 1 is connected to the gate of NMOS 2 in our transmission gate. So we connect. Okay. Similarly, the gate of transmission gate 2, that is the gate of PMOS 2, is connected to gate of NMOS 1. So we'll connect. Or we can just erase this. Okay. So this was for transmission gate 1 and 2. Now the gate of PMOS and NMOS in a inverter, they're connected. So to give the input to the inverter, now these two are again transmission gate. So gate of this PMOS is connected with gate of this NMOS. Similarly, the gate of this PMOS is connected with gate of this NMOS. Okay, and this is an inverter. So the gate of this PMOS is connected with gate of this NMOS. Okay, we can extend this. Okay, so now after connecting or after drawing the gates, next you have to draw the source and drain. So first, the transmission gate 1. We know that the sources and drains in a transmission gate, they are connected. PMOS and NMOS source and drain are connected. So So we'll just redraw this again. Okay, this source and this source connected. Similarly, this drain, connected. Then this is transmission gate 2, where again this source is connected with this source, this drain is connected with this drain. Okay. This is an inverter. The source of a inverter is connected to VDD. So this is connected to VDD. Now the source of the NMOS is connected to ground. So this is connected to ground, and the drains are connected. This drain of PMOS is connected to the drain of NMOS. So now this is also a transmission gate. So the sources are connected, and the drains are also connected. This is also transmission gate. Okay. This is that inverter. So this source is connected to VDD. So and source of the NMOS is connected to ground. So we can connect the ground. We can do one thing. We can erase this. And place it, draw it over here. This is ground, and this is VDD. Okay. So the drains of PMOS and NMOS are also connected. Okay, now after drawing the sources and drains, now you have to make the connection. The output, before going for the output, first see the gate. This is connected to B and this is connected to B bar. So this input is B, which is connected over here, or you can directly connect from here also. Connected, this is B. This input is B. This is B bar and B bar is connected over here. So it's poly and metal overlapping. So this is B bar and this is B. So we need a poly contact now. Poly contact is placed over here. Just marking. This is the poly contact. To do one thing, we can just shift this, erase this area. Okay. And place the poly contact over here. This is the poly contact. Now these gates are connected. Now these gates should be also connected. B is connected to this. Okay, so this is connected to this and these two are connected. So connect from here. This was also B and this is B bar. So B bar means directly you can connect from here, and there is also a metal layer. So I have to place a poly contact. Okay, now after connecting the gates, next you have to connect the source and the drain. This is A and this is A bar. This is connected to ground. This is connected to A bar. So first connect to A bar. This is A bar. A bar, A bar. This is connected to ground. So This is connected to ground, so now this is ground because this is ground. Now after connecting to ground, this is A over. Now the output is obtained. The inputs are ground and A bar, and output is obtained from the drain, common drain. So we'll make a common drain, and this is borrow. This is borrow. Okay. So transmission gate 1 and 2 over. Inverter was already drawn. Now the gates are connected in transmission gate 3 and 4. Next you have to connect the sources and drains. This is A and this is A bar. So A, if this is A, then it has to be connected with this poly, and this is A bar, means this has to be connected to this metal. So this A bar can be connected like this because it shouldn't overlap. It can overlap a poly layer, but it shouldn't overlap a metal layer. Okay, we'll erase this part. And redraw. So this is connected like this. It's connected to A bar. So directly connected to A bar. Now A bar is connected, but A can be connected from this side to here. This is A. This is a metal layer from here. This is A. Okay. And you have to place a poly contact here. Okay. Now this is connected. Next you have to connect the output. Output is obtained from the drain. This is the difference. So this is the metal layer, that is metal 1, or you can say this is M1. This is the poly layer. Okay. Now you have to place the contacts. That is, in order to make a contact between the P diffusion layer and the NMOS, you have to place a P diffusion layer and the metal. You have to place a PDC contact. Similarly over here, you can see there are 6 PMOS, 1, 2, 3, 6 PMOS, and each has a source and a drain connected. So total 6 into 2, 12 contacts. So here you have to place the contacts. This is the P diffusion contact. Or the PDC contact. Now the N diffusion layer is connected with the metal layer. In order to place a connection, you have to place a contact. This is a N diffusion contact. That is NDC. Since there are 6 N diffusion layer or 6 NMOS, 2 terminals each, you have to place 12 contacts. So all these are diffusion contacts. Next you have to place the substrate contacts in the VDD and ground layer. This is VDD. This is N substrate contact, N WC contact. Similarly, we have here in the ground you have to place the P substrate contact, or PWC contact. So this is the layout of a half subtractor that is drawn from the twisted schematic.